Hello everyone, this is the video for the extra day on the third lab. I will show you my setup here, which is to measure temperature using an RTD, and I'm going to demonstrate the change of resistance using a multimeter. So here's my RTD. So this is an RTD to measure the temperature, and this is connected to the connection block here, and it's a part of the circuit. But initially what I will do is I'm going to use a multimeter to show you how the resistance of the RTD changes in response to the temperature changes. So the RTD is connected here, and these two wires are connecting this connection block to the multimeter. So now the RTD is measuring the room temperature. Its resistance is around 110 ohms. Now what I will do is I will get this RTD and insert this into an ice bath. So once I did that, so let's see what's going on the multimeter. So see, the multimeter is showing me a decrease in resistance. So remember, this RTD, which is a platinum RTD, is a PTC type RTD, so positive temperature coefficient, which means that its resistance is going to decrease as the temperature decreases. So now I'm going to take it out of, oops, let's turn it on again. So it was in the ice bath. So the resistance dropped from 110 to 101. So now I will take it out of the ice bath. Its resistance is going to increase, but it's going to be a slow process. So this is very important because with the thermocouples you had almost instantaneous response. With this, now the response is kind of slower. Okay, so that's going to be one thing that you have to keep in mind tomorrow. Okay, so let's leave it here. Let me show you the setup a little bit before the measurement is complete, the setup is complete. So I'll take out the leads for the multimeter. So let's put the multimeter away. So now I have two cables here. I attach this to the connectivity board here. And the second one. Let me tell you what cables are here. Let me zoom out a little bit. So I have an analog output here. So this cable provides the excitation voltage at the power terminals here. And power goes from the positive side to the positive side of the reference resistor. And from the negative side of the reference resistor, I have a connection to the connectivity plate. And then finally, from the negative side of the connectivity plate, I have a connection to the negative terminal of the power terminals. So now I have three analog inputs here. The first one is measuring the excitation voltage. The second one is measuring the voltage drop across the reference resistor, and the third one is measuring the voltage drop across our RTD. Okay, so you have every voltage information for your setup. So one key point here is that for this reference resistor, the resistance value should be close to what you are measuring. So remember, this RTD is measuring around 100 ohms, so this has to be around 100 ohms as well. Okay, so it's one key point. So tomorrow you will be measuring the temperature with RTD and with a thermistor, and you have to complete the setup. First, you need to calibrate the sensor. Second, you need to find out for 20 degrees of temperature gradient which one of the temperature sensors gives a better output. Okay? See you guys tomorrow.